Hello. In this video, we're going to go over how to do one of the questions from your hybridization practice day 1 homework sheet. I'm going to pick perhaps one of the more challenging ones. We'll do ICl4 with a -1 charge. Now, some of this information is filled in for you, but we're going to fill in the rest and give you an explanation of how I got that answer. Okay, so let's start. I'm going to switch over to my ink pad here. All right, so let me just get this to be a little bit thicker. Okay. Okay, so ICl 4 minus 1. Now, you have to draw a Lewis structure diagram for this, right? And so that's going to look like, without getting into counting number of electrons, because that's all back to grade 10 review, we know that we're going to have 7 electrons from iodine, well, sorry, 7 from iodine, also 7 from chlorine, from each of the chlorines, which gives us, because there are 5 halogens here, 35 electrons. Now, the important part is here, we have to add that 1 extra electron. So we have a total of 36 electrons to add. Our central atom, of course, is iodine. Then we have all of our 4, try to place those symmetrically, although it doesn't matter for this really. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so we've added 32 electrons. That means we have 4 electrons left. Now, those 4 electrons, the rules are, will then go to the central atom. So we can have a pair of electrons here and a pair of electrons here. Now, this is an overfilled octet. We know that that is possible. So let's see what we have. So we have, in terms of ligands given to you in the worksheet, right, just toggling back, we do have 4, scroll up a little bit, we do have 4 ligands. So it already gave us that. So 4 ligands and lone pairs. Now we have to add up the number of lone pairs. We have 1 lone pair here and 1 lone pair there. So we have 2 lone pairs. Now if we add these together, we get what's called a steric number. So steric number is going to be 6. I'm going to toggle to, I have this open, VSEPR worksheet. And your VSEPR worksheet looks like this. We're going to look at the left here, steric number 6. And it has 2 lone pairs, meaning it is a square planar. So we want to practice, this isn't on our worksheet, but might as well practice this now. This is a square planar molecule. It will look something like this, right? So one of the requirements was, when drawing VSEPR, is to draw the location of your lone electrons. Here, this is drawn in the 3D perspective for all of our ligands, and it also includes the lone pairs. For the purposes of our course, you won't need to draw the orientation or the 3D perspective of your lone pairs. So all I'm going to do for that is place these lone pairs right here, and I can then place the other ligands. One is going to the back like that, another one is going forward, and just the same thing on the other side. That in, okay, there, and that is your square planar VSEPR diagram, as a little addition to the worksheet. So the next part, so we then have, so we know the number of lone pairs. 2, we know the VSEPR shape is square planar. Now our hybridization. Okay, our central atom, make some room here, our central atom is iodine. So iodine is in the 3rd row. And its ground state orbital diagram, only valence electrons if you recall, will look like this. So this is 3s, 1, 2, 3, 3px, 3p, I wrote 2, 3, py, 3pz. It's a halogen, so it has 1, 2, 3, 4, 5, 6, and 7 electrons, right? But we should, at some point, this is a good point now, we should add that extra electron, right? Let's do that. So adding that extra electron then gives a ground state. You can add it later on, but you do have to count for that. Now, adding that extra electron because of the charge, that's a key thing here. In our excited state, we want to create 1, 2, 3, 4 half-filled suborbitals. 4 half-filled suborbitals. We also want to create two lone pairs as well. So currently there is no space at all for these ligands to form. We would need 4 half-filled suborbitals. So where are they going to go? They're going to get promoted. So in our excited state, I'll draw the 3d orbitals. So 1, 2, 3, 4, 5. These are our 3d orbitals. We're going to end up promoting not just one there, and this one there. Those electrons will go over to our 3d orbital. Then we'll have 1, 2, 3, 4 half-filled suborbitals, plus we still have the two lone pairs, one here and the second one over here, and we're well on our way. Okay, so let's do that. Okay, so this pair of electrons, that pair of electrons. Now, this one is now by itself because that's moved on, it's been promoted. This one as well, and they've been promoted here. So up, up, and hybridized states is the final stage. Now, before bonding can take place, all of these suborbitals are going to come together. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Don't need to draw these empty ones here, but I'm just going to fill in electrons now. Let's count. We have 1 from S. Okay, so we write S. We have 3 from P, so we write P. 3. We have 2 from D, so we write D2. Turns out this is an sp3d2 hybridization, and we would fill it in on our last column here, sp3d2, and that's your answer. Hope this helps. I'll see you next time.